Hello, good morning students. We are moving to the last section of surface chemistry, that is emulsions. So what do you mean by emulsion? We know what is dP, what is dm, dispersed phase and dispersion medium. If both dP and dm are liquids, that means dP is a liquid, dm is also a liquid. Such type of colloids are termed as emulsions. Okay. Now, how can we prepare the emulsion? By mixing two liquids, one liquid, other liquid, and if we mix two liquids by using a colloid mill, we have discussed that about colloid mill. So we can call that particular colloid mill as homogenizer. Okay, the particular colloid mill which is used to mix two liquids for the formation of an emulsion is known as homogenizer. So by using homogenizer, we can mix two liquids to form an emulsion. Clear? So what is an example for emulsion? Milk. One of the very best example is milk. So we can use, there is a particular use for emulsion. Clear? What is mean by emulsifier? There are some terms which are related to emulsions. What is mean by emulsifier or emulsifying agent? Both are same. Emulsifier and emulsifying agents are same, which stabilizes the emulsions. The particular substances which stabilizes the emulsions is called emulsifier. Clear? So emulsifier will stabilize the emulsions. Example, sodium palmitate and sodium stearate. Okay, we have talked about the cleansing action of soap in that area. I discussed about what is mean by palmitic acid and what is mean by sodium salt of palmitic acid. Then what is mean by stearic acid and what is mean by sodium salt of stearic acid. So these two are examples for emulsifier. Simply we can say soap is an example for emulsifier, right? So that's the first term, and the second term is about the types. The second thing you have to study about these emulsions is types. So emulsions are classified into two types: oil in water and water in oil. Simply we can say what is meant by oil in water. If dP is oil and dm is water, we can call it as oil in water emulsion or O bar W emulsion. Milk is an example for oil in water emulsion. Clear? So other emulsion is water in oil or W bar. Here dP is water and dm is oil. So water as dP, oil as dm. Example, butter. So simply we can say there are two food materials are there. Milk is O bar W, butter is W bar O. Simply we can easily study these two examples. Clear? Now we are moving to the third one, demulsification. Just opposite to that of emulsification. Separation of dP and dm from emulsions. That means from emulsions, if we separate the dm and dP, we can call that process. And the fourth one is applications. What are the applications of the emulsions or what are the uses? So there is one of the very important use which is called froth flotation. In the next chapter we will be discussing about the froth flotation in metallurgy. One chapter there. So no need to study more about froth flotation now. Now applications. The second one is milk. We are using milk colloid as food. Clear? Then oily drugs contain emulsion. The drugs, certain drugs are there which uses the emulsion. Then disinfectants such as Dettol. So inside the Dettol, emulsions are being used. Then soap as and detergents. So soap and detergent we have already discussed about the sodium palmitate and sodium stearate. So sodium salt of carboxylic acids are called soap and sodium salt of sulfonic acids are called detergents. And the sixth one is about digestion. Clear? During the digestion, here one important thing is there that you have to note. During the digestion, fat with inside our body, fat with alkaline solution of They form a soap solution which causes the emulsification of the rest of the fat. That means we are discussing about the digestion of fat. Clear? So with the alkaline solution, fat forms a sodium soap which causes the emulsification of rest of the fat. So these are the important uses, okay, and important applications of the emulsions. And there are certain other effects about the emulsions. The other one is in petroleum industries. Clear? Petroleum is obtained by mining. You know, is it? So during the mining, petroleum can form an emulsion with the water. Clear? Which destroys the properties of petrol. If you know what happens when petrol is mixed with water. So in petroleum industries, sometimes petroleum with water may form emulsions. Clear? It is actually a harmful effect. We can call it as a harmful effect. Clear? So these are the things we have to discuss about the emulsions. Clear? I think it's clear for you. So if you have any doubt, you can ask later, or you can see the video again. Okay, so you have to move the other section, and the second one is about gels. It is similar to that of emulsions. In gels, DP is a liquid while DM is a solid. That's the difference. Liquid in solid can be termed as gel. We know different type of gels we are using in our daily life. Hair gel is one of the very good example. So what is mean by gel? If dispersion phase is a liquid and dispersion medium is a solid, we can call that particular colloid as gels. Now there are some important terms related to gels. So first one is about VP. The important term is VP or synersis. So what is mean by VP? VP means shrinking. Gel can shrink. How can gel shrink? If gel loses the water molecule. So if there is gel and if it loses the water molecules, it may shrink. So we can call the shrinking of gel due to the loss of water as VP. Similarly, if water enters more into the solid, swelling take place. Clear? So swelling, we can also, the important word is imbibition. So what is mean by weeping and imbibition? They are just opposite terms. Weeping means the shrinking while imbibition means the swelling. Clear? So weeping or synersis, imbibition or swelling are the two important terms about the gels. Then one more thing, thixotrophy. It is related to actually it's an entrance type question. So what's mean by thixotrophy? So when we shake the particular gel with liquids, so if we shake that particular gel with liquid, it loses their semi-solid character. It means if more liquids are present, actually here just listen, dispersion phase is liquid, actually dispersion medium is solid. So when liquid enters more into this gel, what happens? It loses its solid behavior or it loses its semi-solid behavior and show the characteristics of the liquid. And similarly, the reverse reaction take place. That means the liquid again converts into semi-solid. So we can simply that semi-solid gels can be converted into liquid form. Similarly, vice versa. So this is called thixotropy. So on shaking with liquids, gels loses their semi-solid behavior and again changes into gel. Okay. Next one is classification. So gels can be classified like the emulsion. There are two forms, elastic and non-elastic. As we know, with by the name we can easily understand. Elastic gels show elastic behavior. What is mean by elastic behavior? You know, is it? So elastic gels and non-elastic gels. Example for elastic gels are gelatin and agar-agar. Example for non-elastic, which are having there are no elastic behavior for this type of gels. Silicic acid is other example. So gelatin and agar-agar are the examples for elastic gels, while silicic acid is an example for non-elastic gels. Clear? These are the two important terms in the last portion in the surface chemistry. So you have to study the surface chemistry in the following following manner. So listen, what are the things you have to study? The first one is about the NCERT textbook. So to study surface chemistry, you have to read the NCERT textbook from first to last. It is very important thing. So read the NCERT textbook from first to the last page. Clear? After reading the NCERT textbook, if you have any doubt about our video, again see the video. Clear? Already videos are there in your mobile or laptop. So again see your videos, and you have any doubt, write it in your notebook. If you have any doubts, write in your notebook. There will be a specific time to ask as a doubt clinic. So now NCERT questions, it is also very important. So NCERT is our holy Bible or Quran or Bhagavad Gita. So NCERT questions should be done. So it is very important, NCERT questions. Then entrance based questions are there. So entrance based, I have already given I think 50 or 60 questions already it is given. So I will again give 100 questions, entrance based questions later. So you have to do entrance based questions, and from the books like such as Cengage, MTG, Errorless, Pearson, such books are there. So this particular books may be available in your library. So try to do the maximum number of questions, entrance based questions, level 1 questions. Now brain teasing questions are there, level 2 questions. So this should be done only after these 4 things. So first you think about 1, 2, 3 and 4, fourth level questions. Clear? Then only you should have to move to the brain teasing questions. Clear? By this way you have to study the surface chemistry in a proper way, because it is easy to score maximum marks or full marks in surface chemistry, because the number of numerical questions are very less here. Clear? Only direct questions or indirect questions are there, but numerical questions are not available or not possible. Only a few questions are there which is related to gold number, rate of adsorption. I have already given some questions. Such type of questions only will be asked for the entrance examination. So try to study in this manner. So 1 and 3 are very important for your CBSE examination. For the entrance examination, after doing 1 and 2 and 3, 4th should be done for your examination. Then 5th can be done later, brain teasing questions. Okay, do not directly enter into the brain teasing level questions. Okay, so these are the things we have to discuss about the surface chemistry, and study well and all the best. We are directly moving into the next chapter because there are a few time available here. So we can move to the next chapter. So we are moving to the chapter number 3, electrochemistry. This is a very important chapter for your CBSE examination and for your entrance examination. The problem here you may found is about the numerical questions. So this is very important area. So numerical questions should be done. So try to solve maximum number of numerical questions. This is very important. No direct questions may be asked for your entrance examination. So numerical questions will be there. So to study the numerical questions, give more importance for the numerical questions, because it is a part of physical chemistry. So when you study physical chemistry, numerical questions, mathematical calculations should be done. So how to study the numerical questions? First you have to should be very familiar with the equations in this chapter. Equations are very important. Equations as well as derivations. Derivations are for CBSE examination, and equations are for numerical questions in your entrance examination, and try to study some common sense based questions may be asked. So by simply studying the equations you may not be able to do the numerical questions. You should use your common sense also. So to get such type of questions you should be familiar with that type of questions. So try to solve maximum number of questions, numerical questions, in this chapter. At least try to solve 50 or 60 numerical questions, only numerical questions. And totally, for example, you can, if you discuss, if you do 200 questions, out of these 200 questions 80 or 90 questions will be from by using numericals. So try to solve it maximum and learn carefully, watch the videos, and if you have any doubt write it in your notebook and ask in the doubt clinic section. Okay, so we can move to the chapter directly. Okay, so here what is mean by electrochemistry? The word electro and chemistry are there. So here we can convert chemical energy into electrical energy. Clear? Similarly, electrical energy can be converted into chemical energy. Clear? Chemical energy can be converted into electrical energy. This is the example. If you see a battery or cell, in a battery energy is present in the form of chemicals. So inside a battery chemical energy is there. If you use the battery it will give the electrical energy. So from the battery chemical energy is converted into electrical energy. Similarly, we know what is meant by electrolysis. During the electrolysis, you may have studied about electrolysis in the 8th or 9th standard. During the electrolysis, one cathode will be there, one anode will be there, and electricity will be given to this area. And here chemical reaction take place. So you are giving the electrical energy. So electrical energy is converted into chemical energy during the electrolysis. So inside the battery, chemical energy into electrical energy. During the electrolysis, electrical energy into chemical energy. So here conversion of chemical to electrical and electrical to chemical take place. The branch of chemistry which deals with the study of chemical energy into electrical energy or electrical energy into chemical energy is known as electrochemistry. So here we will be discussing about these two sections. Clear? So here the particular area, we have to study about this particular area. Clear? So cells can be classified into two forms. First one is electrochemical cells. Second one is electrolytic cells. So cells can be classified into two. First one is electrochemical cells. Second one is electrolytic cell. Electrochemical cells, some other names are there for electrochemical cell. You may have heard about galvanic cells or voltaic cell. So electrochemical cells are also known as galvanic cells or voltaic cells, and other one is electrolytic cells. So in this chapter the first section is about electrochemical cells and the second section is about electrolytic cells. Clear? So we can directly move into the sections. First one is electrochemical cells. Similarly, electrolytic cells. Two sections are there. So before entering to the differences between electrochemical cell and electrolytic cell, you should know what is mean by electrochemical cells. So what is mean by electrochemical cells? Chemical energy converted into electrical energy take place in electrochemical cells. So battery is an example for electrochemical cell. Here chemical energy is converted into electrical energy. So similarly, electrical energy will be converted into chemical energy in electrolytic cells. Clear? So now we can move into the differences between electrochemical cells and electrolytic cells. So what is the first difference? So what is the first difference? Here electrochemical cells. Here chemical energy is converted into electrical energy. It's the first difference. While in electrolytic cell, what happens? Electrical energy is converted into chemical energy. This is the first difference, right? I think it's clear for you. Just if you say about electrochemical cell, think about the battery. Here you think about battery. Here you think about electrolysis process. Clear? Anode, cathode, like that process. So here electrical energy is converted into chemical energy. This is the first difference. And what is the second difference? Second difference is, if you connect something to the battery will directly give you electrical energy. So that means it is an automatic process, or this is a spontaneous process. While in electrolytic cell, if we give the energy, then only the reaction take place. If we stop the energy, the reaction also stops. So it is non-spontaneous. So this is second difference, spontaneous and non-spontaneous. And what is the third difference? Here the third difference is, here also anode, cathode are present. Here also anode and cathode are present. But the difference is that here the reaction take place in two separate vessels or two separate areas, that we will be discussing later why it happens like that. Here in the same vessel or same area it takes place. So during the discussion you can easily understand why it happens like this one. So anode, cathode in two separate vessels. Here anode and cathode in the same vessel. This is the third difference. Now what is the fourth difference? Here also electrolytes are there. Here also electrolytes are there, but here electrolyte is in one vessel because only one vessel is present. Here are in separate vessels. So here separate vessels are used because two separate vessels are there. Here only one vessel is there. So this is the fourth difference. And the fifth difference is, electrodes should be different. Electrodes should be different. Here electrodes can be same or different. Okay, electrodes can be same or different. And the sixth one is salt bridge. There is a salt bridge is used. Here no salt bridge is used. Okay, you may feel quite difficulty in the classification. It is because we didn't discuss about the electrochemical cells or electrolytic cell. So after discussing these cells, I will again come to this portion. So at that time it will be easy for you to understand this type of differences. So here you should think the first difference, it's very important. Chemical energy is converted into electrical energy and electrical energy is converted into chemical energy. So you should know this difference first, then we will come back again to this portion after discussing these two types of cells. So first you just write this in your notebooks and we can move to the first section, electrochemical cells. And the one more thing we have to discuss is about this electrochemical cells can be classified into concentration cells and galvanic cells. That means electrochemical cells are also known as galvanic cells. But there are certain types of electrochemical cells which should be classified in some other sections. So concentration cells. So it is very important because Actually, both are electrochemical cells, or other name of galvanic cell is electrochemical cell. But the problem is about concentration cells. There are certain other cells which could not be named as electrochemical cells. That particular electrochemicals are termed as concentration cells. It is not important for your CBSE examination, but it is important for your entrance examination. There is only a small difference. Okay, so I will be discussing this area later. Concentration cells are, if you study electrochemical cells in a good way, it will be easy for you to study the concentration cells. There is quite no more different cells are there. So we can move to the electrochemical cells. So we are moving directly into electrochemical cells. So this is the first thing, electrochemical cells. What is meant by electrochemical cells? We have to go through more deeply about the electrochemical cells. One of the very important area. So in this chapter, we will be discussing about the electrochemical cells and electrolytic cells. So the first section is about electrochemical cells. So what is meant by electrochemical cells? Here, chemical energy is converted into electrical energy. So here chemical energy is converted into electrical energy, right? So which is an example for electrochemical cells? Some other names for electrochemical cell is voltaic cell and galvanic cells. Is it? So chemical energy is converted into electrical energy. How it happens? So we have to study about the particular electrochemical cells. So I have to draw two beakers. So here two beakers are there. Inside one beaker, this is a zinc rod. This one is copper rod. So metallic zinc is present, metallic copper is present. What is the charge of this zinc? 0. This charge of zinc is 0. Charge of copper is clear. In metallic state, the charge will be 0. So zinc and copper are there. Then two solutions are there. These solutions are, zinc is dipped in ZnSO4 solution, zinc sulfate, ZnSO4 solution, while copper is kept in CuSO4 solution. So zinc rod dipped in ZnSO4, copper rod dipped in CuSO4. In ZnSO4, zinc has +2 oxidation state, or Zn2+. Here CuSO4, copper is in +2 oxidation state, so Cu2+. So Zn2+ and Cu2+. Zn charge is 0, Cu charge is 0. In metallic state, always the charge will be 0. So here two metals are there, two electrolytes or liquids are there. What are the metals? Zinc and copper. What are the electrolytes? Zn2+ and Cu2+. We can simply avoid these SO4s because no importance for the anionic part. We have the importance only for cationic part. So zinc dipped in Zn2+, Cu dipped in Cu2+ solution, and these two electrodes are connected by, we can call this as electrodes. These metals as electrodes and these as electrolytes. So these electrodes are connected by a galvanometer in a metallic way. So there is a metallic connection in between two electrodes and one galvanometer is present. Clear? Then in these two electrolytes are connected by a U-shaped tube. So these electrolytes are connected by a U-shaped tube which contains certain materials. So this U-shaped material tube contains certain materials. Clear? So we can call this tube as salt bridge, and this is galvanometer. So here the setup is zinc rod, copper rod. These two are electrodes. Zn2 plus and Cu2 plus, these two are electrolytes. There is a U-shaped tube called salt bridge, and one galvanometer is there. So this is the experimental setup of an electrochemical cell. Clear? This is an example for electrochemical cells. Then what happens here? Here the reactivity or activity of zinc is more than that of copper. So zinc is more active than copper. Clear? There is a series which is called standard reduction potential series. So according to standard reduction potential series, zinc is more active than copper. That means zinc oxidizes and copper reduces. Or here, when zinc oxidizes, what happens to zinc? Zinc becomes Zn2 plus 2 electrons. Zinc gives Zn2 plus 2 electrons. What happens to copper? Okay, you have to study about the series first, then only you can understand what is meant by this one. The important terms in this series are zinc, hydrogen and copper. Clear? The reduction potential, this is the reduction potential series. Here the reduction potential of zinc is minus 0.74 electron volt. For hydrogen it is 0. For copper it is 0.36 electron volt. So here for zinc it is negative potential, copper it is positive potential. It means that if we connect zinc and copper, zinc will be oxidized, copper will be reduced. So here what happens to zinc? Oxidation. What happens to copper? Reduction. So according to reduction potential series, zinc is more active than copper. So here what happens to zinc? Oxidation take place. Oxidation means what? Oxidation number increases. So here the oxidation number is 0, here oxidation number is plus 2. So Zn0 becomes Zn2 plus. So here oxidation take place. I think it is clear for you. So during the oxidation, zinc is becoming Zn2 plus. Zinc is becoming Zn2 plus means this zinc will enter into the liquid part, because this liquid is Zn2 plus. Zinc is becoming Zn2 plus. So here zinc converts into Zn2 plus while 2 electrons are there. What happens to the 2 electrons? That 2 electrons will move through this metallic part and reaches the copper rod. Okay, around the copper rod there are Cu2 plus ions are there. So what happens to the 2 electrons? 2 electrons are having negative charge. So these 2 electrons coming from the zinc will combine with this surrounding Cu2 plus ions to form Cu2 plus 2 electrons gives Cu. Okay, so 2 reactions are there. What are the 2 reactions? Zinc is converted to Zn2 plus 2 electrons, because zinc will show oxidation reaction. According to the reduction potential series, if we connect zinc and copper, zinc oxidation happens for zinc and reduction happens for copper. So zinc will be converting into Zn2 plus and 2 electron. That Zn2 plus will be available here. It enters into the liquid and 2 electrons are there. These 2 electrons will move through these electrodes and reaches the copper rod. Around the copper rod, Cu2 plus are there. Negatively charged electron will combine with the positively charged Cu2 plus to form. The charge will be get cancelling. So Cu. So Zn gives Zn2 plus 2 electrons. Cu2 plus 2 electron gives Cu. So here 2 plus is becoming 0. So this is reduction. So oxidation reaction, here a reduction reaction. I think it's clear for you. So this is, if I say this is an example for electrochemical cell. Here two parts are there. One part is zinc, other part is copper. So if this one is the cell, this is a half cell, this one is the other half cell. So two half cells are there, zinc half cell and copper half cell. What happens to this half cell? Oxidation take place. What happens to this half cell? Reduction take place. So if this one is the cell, both reactions are happening simultaneously. So what happens? We should have to combine these two, oxidation and reduction. So Zn plus, just make this gives here, Zn plus Cu2 plus 2 electron. This is the LHS, left hand side of these equations. Here the right hand side, Zn2 plus 2 electron give plus Cu. 2 electron get cancels. So what happens? Zn plus Cu2 plus gives Zn2 plus Cu, and this is reduction and oxidation. We are combining reduction and oxidation together. So here both reactions are happening. Zn0 becomes Zn2 plus. That means oxidation number increases. So oxidation. Cu2 plus is converting into Cu. That means oxidation number decreases, reduction. So here reduction, here it is oxidation. So this is a redox reaction. So in this cell, redox reaction take place. I think it is clear for you. So this is the cell, two half cells are present. This is the oxidation half cell, this one is the reduction half cell. So in oxidation half cell, zinc is present, so zinc is converting into Zn2 plus 2 electron. In reduction half cell, Cu2 plus is converting into Cu by accepting these 2 electrons. So the overall reaction happens in this cell is a redox reaction. The area where the oxidation take place is called anode, and where the reduction take place is called cathode. So here this is the anode, this one is the cathode. Clear? So what happens to the electrons here? Electrons from zinc will move to the copper through this galvanometer. Movement of electron is called electric current. Is it? What is meant by an electric current? The movement of electron from one area to other area is called electric current. So here movement of electron is taking place. But what is the direction of current? Just opposite to that of movement of electron. So here the movement of electrons are from zinc to copper. So the direction of current is from copper to zinc. So galvanometer show a deflection towards the left side. Clear? It indicates that the direction of current is from copper to zinc. Why it is like that? The direction of movement of electron is from zinc to copper. So direction of current is just opposite, which is indicated by the galvanometer. Clear? If we keep an ammeter here, we can measure the amount of current as ampere. If we keep a voltmeter here, we can calculate the potential difference or voltage here. Clear? I think it's clear for you. Now we have to discuss about this salt bridge. What is the use of this salt bridge? This reaction is happening. This is showing the this will show the indication. So why we use this salt bridge, which contains certain things. So what is mean by a salt bridge? So salt bridge means it is a U-shaped tube which is filled with a jelly type material called agar-agar with an ionic compound such as KCl or KNO3, like that. So it should be an ionic compound. So agar-agar with an ionic compound is mixed together, forming a paste like material which is filled in this U-shaped tube. So inside the U-shape, a jelly type substance is there, agar-agar mixed with the, so agar-agar plus KCl, ionic compound. Clear? What is the use of this salt bridge? There are two uses for this salt bridge. First use is to complete the circuit. Complete the circuit. Complete the circuit means here the movement of electricity or movement of electrons are from one point to other point. So to complete this circuit, that means we can say, if I say zinc rod, copper rod, Cu2 plus electrolyte, zinc electrolyte. So to complete a circuit, it needs a salt bridge. So that is the first thing, complete the circuit. Otherwise, flowing of electron will not take place. Circuit should be completed. So the first use or first duty of the salt bridge to the complete the circuit. And what is the second one? Second one means ionic balance. Ionic balance means here what is happening, zinc is converting into Zn2 plus. So concentration of Zn2 plus is increasing during the reaction because all zincs are converting into Zn2 plus. So here positive charge is increasing, Zn2 plus is increasing. Now what happens here, Cu2 plus is converting into Cu here. So here positive charge decreases, Cu2 plus is converting into Cu, that means 0 oxidation state. So here positive charge increases, here positive charge decreases. So after certain times there will be an ionic imbalance in between these two cells. So to make it balanced, we should use an ionic compound. Here K plus is there, Cl minus is there. Clear? So here positive charge is decreasing time to time. So K plus will move towards this electrolyte, Cl minus will move towards this electrolyte. So this negative charge will reduce the positive charge present in this beaker. This positive charge will increase the positive charge here. So here what is happening here? Positive charge is reducing. So we have to increase the positive charge here in this electrolyte. To increase the positive charge, K plus will help you. Similarly, here what's happening? Zinc is converting into Zn2 plus. So positive charge is increasing. So we have to reduce the positive charge to balance. So Cl minus will enter into here to reduce the positive charge. I think it's clear for you.